Hello, good morning everyone.
Good morning, ma'am.
Good morning now. So let's start with Naive Bayes Classifier, and today we will be discussing one example. Rather, we are going to solve one problem by making use of this Naive Bayes Classifier. So in fact, in the last class, we had a detailed discussion about this most popular classifier under the category of Bayesian learning, and that is the Naive Bayes Classifier. So let us have a recap. So in Naive Bayes Classifier, actually we had few assumptions initially. So what are those assumptions? One of the assumptions is the attributes or features, those actually describing the instance in the data set, are independent of one another. And we mentioned that the attributes have equal contribution. Right? So these two were the important assumptions that we had. So with these assumptions, we discussed our Naive Bayes classifier, and we come up with one expression that will provide us the class of the sample instance. So we have seen the expression of Naive Bayes classifier as y and b is equal to R max yj belongs to capital Y, probability of yj into product of probabilities of xi given yj. I varies from 1 to n. So here we are assuming that we are having a target function f that accepts the instance as x and produces the outcome as y. And every instance x is described with n number of features like x1, x2, x3 up to xn. Right? So our Naive Bayes classifier is given as y and b equal to R max yj belongs to capital Y, probability of yj into probabilities of xi given yj's for all attributes like xi's. So if I am having 4 attributes, then I'll be having 4 probabilities like probability of x1 given yj, x2 given yj, x3 given yj and x4 given yj. And what is this yj? In fact, y is the set of labels or set of classes. So individual yj is giving us a class label. So we are going to compute this quantity for every class, right? And for whichever class this quantity is maximum, we are going to assign that class to our sample instance or our test instance, right? So this is what we have discussed in the last class. Now we are going to see one example how to solve a problem by making use of this Naive Bayes classifier, right? So may I proceed? Yes. So I hope you must have recalled whatever we discussed in the last class. May I proceed with the example?
Yes, ma'am.
Fine. So let us see one example. We have been provided with the training data. So we have gone through this training data earlier, and in this training data we are having 14 instances, right? We are having 4 attributes or 4 features: outlook, temperature, humidity and windy. So these are 4 features, right? So number of features n equal to 4, and this is our target variable, or we may say this is our dependent variable, play tennis, right? So given these 4 weather conditions, we are supposed to predict whether to play tennis or not, right? So this is the training data that is available with us. So presently we are having 14 instances in our training data set. So by making use of this training data, we would like to predict if we are having a new instance, say today, which is given as sunny, hot, normal and weak. So these are the 4 attribute values. So if outlook is sunny, temperature is hot, humidity is normal and winds are weak. So if these are the weather conditions of today, then we would like to predict whether one should play tennis or not. So this is the problem that we would like to solve, right? And we have been provided with the training data with 4 attributes, and the target variable is play tennis, right? So how to proceed now? So what we are going to do here is, by making use of this training data, we need to find out probability of xi given yj for each xi in x and yj in y. So xi stands for individual attribute or feature. So for every feature, we need to compute the probability, conditional probability of xi given the label yj. Right? So let us look at one example here. So the first instance in the table, first instance in our given training data set. So what is the first instance? This row, where we are having outlook equal to sunny, temperature equal to hot, humidity is high and windy is weak. And for these weather conditions in our training data set, the value for our target variable play tennis is no. So if we consider this first instance in our data set, then this x, that is my instance, is given as sunny, hot, high, weak. So this is the feature value for x1, this is the feature value for x2, this is the feature value for x3, and this is the feature value for x4. And for this instance, the prediction is no. Don't play tennis. Right? Now, what actually we would like to do is, we would like to compute the probability of y given x. So how we are going to interpret this? This can be interpreted as probability of tennis, we are considering this instance. So probability of not playing tennis given that weather conditions are sunny outlook, temperature is hot, humidity is high and weak winds are there. Right? So under these conditions, we need to find out the probability y given x, probability of not playing tennis. Right? So if we want to find out that, what computations we need to have? So first of all, for each feature or for each attribute and for each distinct value of the attribute, we need to compute probability xi given yj. Right? I'll repeat, for each attribute and for each distinct value of that attribute, we need to estimate the probability of xi given yj. And for each target value, we need to estimate the probability of yj. So that is the class probability, right? So these two types of quantities we are supposed to compute based on given training data set. So let us see, for given training data set, how we are going to compute these quantities, right? So we are having here 4 tables for 4 attributes. This is the table for attribute outlook. This is the table for attribute temperature, humidity and wind. So how we have computed all those values? So let us see the first attribute outlook. So for first attribute outlook, we are having 3 distinct values. And what are those 3 distinct values? We are having sunny, overcast and rainy. These are 3 distinct values for outlook. Now, we are having, please look at this, we are having here this value 2 for the row sunny and the column yes. So see here in this table, the number of rows equal to the number of distinct values for this attribute. And what are those columns? This yes is the value for our target variable. No is also value for target variable. Then we are computing probability for yes and probability for no. Now, let us see how we have computed these values. So this is the training data set that is available. So we are talking about this attribute outlook and the value for this outlook variable as sunny. So if we look at this data set, we are having these 5 instances where the outlook value is sunny. Right? Now, what we are going to do next, for these 5 instances, we will see how many of the instances are predicted as no and how many instances are predicted as yes. So if we look at these 5 instances where the outlook value is sunny, we find that 2 instances are having the value yes, play tennis value yes, or the prediction as yes, right? So here this 2 indicates that we are having 2 instances for which the outlook value is sunny and play tennis value is yes, right? Similarly, we are having 3 instances for which the play tennis value is no, right? And the outlook value is sunny. So we are having this number over here, 3 for no, sunny no. Okay, now what next we are going to do? We are going to compute the probability of this yes and probability of this no. So how we are going to compute that? Now, if we look at once again this training data set, how many instances in training data set are having the play tennis value as yes? So let us count the number of instances with play tennis value as yes. This is our class, right? So we are having 1, 2, 3, 4, 5, 6, 7, 8 and 9. So we are having 9 instances with play tennis value as yes. So obviously remaining 5 instances are having the play tennis value equal to no, right? So what we are going to do next is, while computing the probability of yes for this attribute outlook and value of outlook is sunny, we are having 2 instances having play tennis value yes. So probability is 2 divided by 9. So out of total 9 instances that we have as play tennis value equal to yes, 2 instances are having the outlook value equal to sunny. So the probability of yes, right, for this outlook value sunny is 2 divided by 9. Similarly, total number of instances with play tennis value no are 5. Out of those 5, 3 instances are having outlook value sunny. So probability of no for outlook value sunny is 3 divided by 5. Right? Similarly, we can compute these probabilities for remaining 2 attribute values overcast and rainy. So if you once again refer to our training data set, you may find that we are having 4 instances with outlook value as overcast, right? And all those 4 instances, 1, 2, 3 and 4, all these 4 instances are having the play tennis value equal to yes. So here we are having overcast and play tennis yes, 4 instances, and we do not have any instance such that outlook value is overcast and play tennis value is no. So we are having here the value 0. So once again, the probability of yes for outlook equal to overcast is 4 divided by 9, and similarly probability of no for outlook equal to overcast is 0 divided by 5. Similarly, we may compute for this outlook value rainy. Right? So this is how we are computing the table for each attribute. So this is my attribute, say x1. For this attribute x1, I am having 3 values, and for all these 3 values, we have computed the probabilities for yes and no. So here my y is set of labels, and this is yes and no. So this is my yj value. So y1 and y2. Are you getting me? Yes? Have you understood how to compute all those probabilities? Yes? Yes, anybody? Is there any doubt? Yes?
No.
So have you understood how to compute all those probabilities given the training data set?
Yes, ma'am.
Fine. So by making use of the same training data set, we have computed actually all those probabilities for 4 different attributes that we have. So once again, let me explain how, say for example, for humidity attribute, we are having the value as normal, and for probability of yes, for this humidity value normal, we have computed the value as 6 divided by 9. So how to interpret this? This is the probability of normal humidity given tennis is played. So we are having the probability of humidity equal to normal given play tennis equal to yes. And this probability is computed as 6 divided by 9. Okay. Now, similar to this, in fact, we are also computing class probabilities. Right? So see here how we have computed the class probabilities. So we are having 2 classes, yes and no. Okay. So number of instances with play tennis value equal to yes are 9, and number of instances for play tennis no equal to 5. So total instances that we have are 14. So probability of yes is 9 divided by 14 and probability of no is 5 divided by 14. So this is how we have computed these class probabilities. Okay. So once we are having all these computations done, we are going to actually formulate now our solution. So what we are going to do next? Once we are having all those quantities computed for all the attribute values and the class probabilities, we are going to formulate the solution as follows. So what we would like to predict: if the new instance today is described as sunny, hot, normal and weak, predict whether one should play tennis or not. Now, we are having this expression for Naive Bayes Classifier. So YNB is given as argmax Yj belongs to capital Y, probability of Yj, summation I equal to 1 to n is number of attributes, probability xi given yj, right? So here, as I stated earlier, y is the set of attributes, y is the set of class labels, and we are having 2 classes, yes and no. Okay, so for yes, we are going to compute this quantity. For class label no, we are going to compute this quantity. And for whichever class this quantity is maximum, we are going to declare that class for this instance. So let us see how we are going to do that. So as we are having 4 attributes, let us try to expand this expression. So what we have, YNB equal to argmax Yj that belongs to Y, probability of Yj into, this is the product term. So product of all the probabilities, right, with respect to individual attributes. So we are having here probability x1 given yj into probability of x2 given yj into probability of x3 given yj into probability of x4 given yj. We are having n equal to 4 attributes. Right? Now, we want to compute now the probability of playing tennis, and also we want to compute probability of not playing tennis. Okay, so how we are going to do that? So simply see here, we are going to compute probability of playing tennis as probability of yes given today. What is this today? Today is this instance for which we would like to predict. So probability of yes given today is computed as probability of yes. So this yes is my yj. Right? And this today is actually my x. So probability of yes into probability of x1 given yj. So the first attribute in our data set x1 is outlook. So probability of outlook equal to, we are going to predict for this instance. So outlook value is sunny. Given yes, we are computing the probability of playing tennis. So we are computing for class yj equal to yes. So here we are having probability of yes into probability of outlook equal to sunny given yes into probability of temperature equal to hot given yes into probability of humidity equal to normal given yes into probability of wind equal to weak given yes. So here this x1 is outlook, this yj is yes, x2 is temperature, x3 is humidity, and x4 is wind. These are the four attributes or features we are having. Okay, and we are computing the probabilities for given. We are considering the probabilities for the given attribute values. So we want to compute, we want to predict whether one should play tennis or not for today. And what are the weather conditions for today? The outlook is sunny, temperature is hot, humidity is normal, and windy is weak. Right? So this is how we are going to compute the probability of playing tennis. Similarly, we are going to compute the probability of not playing tennis with this expression. So probability of no given today is computed as probability of no into probability of outlook equal to sunny given no into probability of temperature equal to hot into probability of humidity equal to normal given no into probability of wind equal to weak given no. So we have come up with these two formulae for computing the probability of playing tennis and the probability of not playing tennis. So we need to compute now these probabilities. Probability of yes given today and probability of no given today. And whichever is the maximum probability, that would be the class.
No, ma'am.
Fine. So let us proceed now. This is what we want to compute or predict. And we have come up with the probability of playing tennis and probability of not playing tennis. So these two are the expressions. Those we have found out. Now, what we are going to do simply is we are going to substitute the values of all these probabilities from whatever we computed earlier. So these tables are ready with us. So simply now what we are going to do is we are going to substitute the respective values from all those tables. So here probability of yes given today equal to probability of yes. So what is probability of yes? So these are actually the class probabilities, right? So probability of yes is 9 divided by 14. So we are having that value substituted over here. Okay. Now, what next? Probability of outlook equal to sunny given yes. So we are referring to this particular attribute, outlook. So probability of outlook equal to sunny. That means we need to refer to this row. Given yes. So what is the value? 2 divided by 9. So we are having here that value substituted. Similarly, probability of temperature equal to hot given yes. So once again it is 2 divided by 9. Then probability of humidity equal to normal given yes. So this is 6 divided by 9. And probability of wind equal to weak given yes. So once again this is 6 divided by 9. Right? So after substituting all those values, probability of yes given today comes out to be 0.0141. Right? Similarly, now we are going to compute the probability of not playing tennis. Probability of not playing tennis. So on the similar lines, actually we are going to compute this. So probability of no given today is equal to, once again refer to our computed values. Probability of no, it is 5 by 14, right? Probability of outlook equal to sunny given no. So probability of outlook equal to sunny given no, that is 3 divided by 5. Probability of temperature hot given no, it is 2 divided by 5. Probability of humidity equal to normal given no, 1 divided by 5. Probability of wind equal to weak given no, it is 2 divided by 5. So this product comes out to be 0.0068. Okay. Now, as we are talking about the probabilities, the probability values. Yes.
Ma'am, is there any relation between these two probabilities? Means probability for yes today and probability for no today.
Yes. See, actually,
What is
the
that?
probability of yes given today plus probability of no given today should be equal to 1. Right? Now, if this should be equal to 1, what we need to do simply is we need to normalize those probabilities. So how we are going to normalize? Probability of yes given today is normalized like 0.0141 that we have computed divided by summation of these two. So it comes out to be 0.67. And this probability of no given today comes out to be 3. So probability of yes given today is 67% and probability of no given today is 33%. So obviously probability of yes given today is maximum out of these two, and that is why we are predicting that the tennis should be played today. So today is this weather condition. So we are asked to predict whether one should play tennis or not on this day. So we are going to predict here that tennis should be played today. So prediction is yes. So this is how our problem. Okay. I hope you must have understood whatever we have done. Okay? Now, let me give you this exercise based on the same data. So, you take down please, for the same training data, if new instance day equal to sunny, cool, high, strong, whether one should play tennis or not. For the same training data, if the weather conditions for the day are outlook equal to sunny, temperature is cool, humidity is high and windy is strong, predict whether one should play tennis or not. So please try this.
Not.
See here we are having the data. See here we are having this data that has been computed. So come up with probability of yes given today and probability of no given today and predict whether on this, what is the instance day, what is the instance day for which we would like to predict. The instance is sunny, cool, high, strong. So what is this probability of yes given day and what is probability of no given day? Anybody who have computed the
Ma'am, for probability of yes today is 0.0053 and for no is 0.0205.
0.0205 or 6 after rounding. Okay, so after normalization what we are getting is probability of yes given day is 0.2 or 20% and probability of no given day is 0.8, that is 80%. So which probability value is highest? So obviously probability of no given day is greater than probability of yes given day, and that is why we may predict that one should not play tennis on this day, right? So our prediction is no, one should not play tennis on this day. Right? So this is how we need to come up with the solution. I hope all must have understood. If you have any doubts, please let me know.
No, ma'am.
Fine. So with this, we have covered this Naive Bayes classifier. So let us talk about few subtleties for this algorithm. So, as we stated earlier, this Naive Bayes classifier is actually having few assumptions initially, and the assumption made by this classifier, that is the conditional independence assumption. So, attributes or the features are independent of one another. In fact, if we look at the real world situations, this independence assumption is not generally correct. But still, this Naive Bayes algorithm factors. So in fact, though we are having this assumption initially that all the attributes should be independent of one another, In reality, while solving the real world problems, this assumption may not be true. But still, even though this assumption is not true, this Naive Bayes algorithm works well in practice. Okay? Now, the second point to be noted is, what if none of the training instances with target value yj have attribute value xi? What does this mean? For example, in our case, there is no instance with target value play tennis equal to no. So there is no instance such that play tennis equal to no, and outlook value is overcast. Right? So in our given training data set, we do not have any instance such that outlook value is overcast and play tennis is no. Right? So in this situation, what we have is we are having probability of xi given yj equal to 0. So what is this xi in our case? Xi is overcast, outlook equal to overcast. So outlook equal to overcast given no is actually 0. And if this probability of xi given yj is 0, ultimately this product will be equal to 0. Are you getting me? Yes? Are you getting me? Yes. In our case, for outlook equal to overcast, we do not have any instance such that play tennis value is no. Right? So obviously the number of instances for this condition is 0. So probability of xi given yj is 0. And if this probability of xi given yj is 0, then obviously the product probability of yj into probability of xi given yj equal to 0 is 0. Right? This means that if this is the situation, we may face two difficulties. What are those two difficulties? This NC divided by N, or this probability, actually produces a biased underestimate of the probability. So this value actually produces a biased result or biased underestimate of the probability. So when this probability estimate is 0, this term will dominate the Bayes classifier. So the reason is that the quantity that we are calculating by Naive Bayes classifier equation requires multiplication of all the probabilities, right? And if one of the probability values is 0, then obviously this value dominates the result and this entire quantity becomes 0. Right? So, if we would like to avoid this difficulty, what is the solution? The solution is the Bayesian estimate known as M estimate. So, what does this mean? So, see here, this M estimate assumes that this probability of xi given yj the probability of xi given yj is assigned this value nc plus mp divided by n plus m. So earlier this probability of xi given yj was computed as nc divided by n. So number of tuples satisfying the given condition and divided by total number of tuples for that label yj. Right? So this is how we were computing the probability xi given yj earlier. But now the solution is, instead of computing this probability as nc divided by n, what we are going to do is we are computing this probability as nc plus mp divided by n plus m, where this n is the number of training examples for which y value is yj, nc is number of examples for which y equal to yj and x equal to xi, is the prior estimate for probability of xi given yj, and m is actually the weight given to this prior. That is, we are assuming some number of virtual examples. Right? Why? Because we do not want to have this probability as 0. And that is why we are assuming few examples. Virtual. This means, but still we are assuming that there are some examples. And this is how we are using this m. So ultimately, even though this nc value is 0, we are adding some value m into p into that. And that is how this entire probability will not become 0, but it will have some value. And as this will have some value, this entire product will not become 0. Right? So this is a simple solution known as M estimate. Right? That is being used practically to overcome this problem. Right? So these were the important details of the Naive Bayes algorithm that we wanted to note. Right? So with this, actually we have completed discussion about the Naive Bayes classifier, and in fact we have completed the discussion about this unit number 4. Right? So we have come to the end of unit number 4. These are the references, those we have used for the discussions under all the concepts of this unit. So I hope you must have enjoyed this probability theory and Bayes learning for prediction. Right? I'll be providing you several exercises, the problems to solve by making use of these various algorithms, those we have studied under this unit. If you have any doubts, please let me know. Otherwise, we are going to conclude the session. And next time, we'll start unit number 5 that deals with artificial neural network and support vector machines. So comparatively, unit number 5 is lengthy because we are going to cover 2 important algorithms or 2 important techniques, right? ANN and SVM. Right? So next time we'll start unit number 5. I hope you must have understood the concepts under this unit. If you have any doubts, please let me know. So let's stop today. Thank you.